Welcome to lesson 20. Today we're looking at exponents, square roots, and area of rectangles. So basically how exponents and square roots fit into our understanding of area of rectangles. To do this, we're going to kind of break things apart piece by piece. Here we go. We start by looking at exponents. When we look at a number with an exponent, we see two different parts. First of all, we see the base number. And then, of course, we see the exponent itself. And so in the end, what we see is we see a relationship between the base and the exponent. Basically, what it's saying is that 4 to the 5th power should be written or solved in this way. There are actually 1, 2, 3, 4, 5. That's where the 5 comes from. 5 4s. And so if we were to multiply all of that together, right, 4 times 4 is 16. 4 times 4 is also 16. 16 times 16 is 256. And then I pulled out my last 4 to get a final answer of 1,024. All right, so we have that process. All right, we can also look at our second one, 10 to the 3rd power, which would really be like solving this problem, right? Which gets you an answer of 1,000, which also points to our shortcut is when you have powers of 10, right? We take the 1 and we add that many zeros, right? Put the 1 down and there were 3 zeros. 1, 2, 3, okay? So we have this idea, all right? Here's a couple to try on your own. 3 to the 3rd power and then 2/3 to the 2nd power, all right? Go ahead, pause the video. Give it a try. From here, now that we know how to solve and figure out our exponents, we want to be able to work with them also. So if I were to take 4 to the 2nd power and subtract 2 to the 3rd power, first of all, what would the answer be? Is it even going to work? All right, so 4 to the 2nd power is the same as 4 times 4, or 16, minus 2 to the 3rd power, which is the same as 2 times 2 times 2, which of course equals 8. So 16 minus 8 equals 8. And so we have another example just like that. All right, working with those ideas. Okay. From here, we can start to see, are there relationships between it? If we have the same base, right? And that's key, that you have the same base. If you have the same base, how is that going to affect our exponents when it comes to solving for n here, right? Well, if we look at this, we can see, okay, 2 times 2, that's the same as 2 times 2. And just like this is the same as 2 times 2. And this symbol, of course, is multiplication, which is times. And so in the end, we get 2 times 2 times 2 times 2. Or in other words, 2 to the 4th power. And so in a sense, if you look at it, we took this exponent and we kind of added it to this exponent, right? Of course, you have to have the same base, right? Got to have the same base, right? So if that's how multiplication works, see if you can figure out this one, right? What happens if you're dividing, right? If the relationship here is kind of adding the exponents, right? We added exponents. What do you think might be the relationship here if we are dividing two different numbers, right? Divide these two, what's it going to be, right? Okay, if you can't figure it out, just break it down and then cross things out, okay? All right, next side of it, of course, is understanding square roots, all right? So we got this sweet little symbol here. We call that a radical, all right? It's called a radical. Radicals, of course, tell us to, when there's radical and there's nothing right here, eventually we're going to learn about what happens when you put what's called an index there. When you have nothing there, how do you solve this, right? What this symbol literally is saying is what times what equals 16. And what it wants to know is, what is it? What's the right answer? And so as I look at 16, I say, okay, what times itself equals 16? Well, I know 16 is 4 times 4. And so up on top, I'd say 4 is the square root of 16. Right? At the same time, I'm going to come over here and I'm going to look at 121. Oh, 121. That one's not as well known. Oh, sure it is. You know this one just fine. As we look at this, right, we can start using square roots we do know to help us solve things, right? We know the square root of 100 is 10, because 10 times 10 equals 100. And you probably know the square root of 20 is 400. So it's got to be in between those two, right? Now, obviously, it's much, much closer to 100. So even if you don't know have this one memorized, like you probably should, you could very quickly figure out that 11 times 11 equals 121. So our square root of 121 is 11. Right. Cruising right along. Uh-oh, that's not what I wanted. Go ahead and solve this little challenge. All right, from here we move into, well, how does all this work with area? We know to find area of a rectangle, it's length times width. We have that idea in our minds. But how does this apply to square roots and to area, or to exponents? That's the word I'm looking for. The fact is there's still a relationship, right? Because our length is always going to have a label. And our width is usually going to have the exact same label. And in the end, we're not just multiplying two values, but we're also multiplying our labels. And that allows us to get area. Let's try an example together to figure this out. Right? So we're given information about this rectangle. It's 7 inches by 2 inches, 7 inches by 2 inches. All right. If I want to find area, I'm going to take the length times the width. If only my screen was working better. Right? I know the length is 7. I know the width is 2. Right? But I can't forget that I'm also multiplying inches times inches. And so I can throw that into my problem. So 7 times 2 is, of course, 14. Right? And inches times inches is inches squared. Right? There's our exponent. We're starting to see a relationship. Things are good. Right? So how do square roots work in? This is where we can kind of pull in the idea of squares, because squares are a special kind of rectangle. Right? We see the perimeter of a square is 12 inches. Right? Perimeter, so that means right, perimeter of a square is 4 times s. Right? But it wants to know the area. Okay, so 4 times s, or a side, gives me an answer of 12. That means 12 divided by 4 is going to give me a side of 3. Right? And from there, then, we can now find the area. Area equals length times width. 3 times 3. Oh, right? Very, very similar to how exponents work, right? 3 times 3 is the same as 3 squared, right? And from there, then we want to add a label, right? Inches, can't forget, we also did inches got squared, and so our final answer would be 9 inches squared. Did I just do your sample problem? Maybe I was being nice, gave you all those other ones, didn't want to throw another one at you. Yeah, that's it. All right, that's our walkthrough of area. That part of it should definitely be reviewed. The other parts are, they are what they are. All right, have fun with them, think it through, work hard, do your best. That's it for lesson 20.